For the quiz 3 practice, number 1 through 4 is just simplifying radicals. So for number 1, I would go ahead and break down 120 using 10 and 12. And then I would write the numbers at the end of my branches in order. So I have 3 2s, a 3, and a 5. And then I would find all my pairs. So it looks like I only have one. So the one pair goes on the outside of the radical, and the leftover numbers, I would multiply those and put them on the inside. So 2 times 3 is 6, and 6 times 5 is 30. So my final solution would be 2 radical 30. Okay. And number 2, I would also go ahead and break down 60 since it's not a perfect square. And then I would just keep breaking that down until I couldn't break it down any further. So now I have a 2, 2, 3, 5, and I have 8 x's according to the problem. So I find all my pairs, and those go on the outside of the radical. So we have 1, 2, 3, 4 pairs of x's. That means x to the 4th. The 2 also is on the outside. The leftover 3 times 5 goes back on the inside. Okay, number 3, these are perfect squares. So the square root of 25 is just 5, and the square root of 49 is 7. That can't reduce, so I just leave it. Okay, in number 4, we have the square root of 36, which is 6, and the square root of 81, which is 9. But 6 nines does reduce by 3. So 6 divided by 3 is 2, and 9 divided by 3 is 3. For number 5, we need to plug these numbers into the quadratic formula. So our a value is 1, our b value is 4, and our c value is negative 3. To plug them in, we start here with this negative b. So x equals a negative, and then put the 4 in. Okay, then inside of the radical we have b squared, so that would be 4 squared, minus 4, times a times c. So a is 1, and c is negative 3. You put this over 2 times a, where a is 1 again. And then we simplify. So we have negative 4, plus or minus 2 times 1 is 2. In the radical, we have 4 squared, which is 16. A negative 4 times 1 is negative 4, and negative 4 times negative 3 is positive 12. Then, we simplify the radical again. So negative 4 plus or minus 28 divided by 2. But 28 is not a perfect square, so we need to break it down. And it breaks down to 2, 2, 7. This gives me a pair of 2's on the outside with a leftover 7 on the inside. So this part becomes 2 radical 7. Okay, so I replace that with the 2 radical 7. And then we discussed in class that if you have a number in all of these spots here that can be reduced by the same number, you do that. So 2 goes into all of those. So negative 4 divided by 2 is negative 2. 2 divided by 2 is 1. 2 divided by 2 is 1. So for our final answer, we say negative 2 plus or minus 1, but we don't need to write that 1, the square root of 7, and then that is all over 1, but when you have it in a fraction, you don't really need to write the 1 at the bottom. Okay, for the last 4, you're just picking which method is the best way to solve. You're not actually solving it. So for number 6, I would try factoring first. Okay, so 12 to 7, 3 and 4 would work. So since it works, it's factoring. And it has an x term. So you try factoring first. Okay, here we have an x squared term but no x. So if it has no x term, automatically it's A, finding square roots. 8, we try factoring again because we have those 3 terms equal 0. So 14, trying to get to 3. Well, the only factors of 14 are 1 and 14 and 2 and 7. Neither of those get to 3. So this is not factorable, which means you use the quadratic formula. And then lastly, for number 9, you do not have the x term again, so of course that's going to be A, finding square roots.